right, so today we are going to cover strings. We're going to start covering strings. Of course, string processing is going to bleed into next week a little bit. Remember that on Wednesday we are going to be doing a review. The strings are not going to be on the midterm at all. The midterm review will take up the entire time on Wednesday. It'll take the form of me bringing in last year's, or I guess last semester's midterm, and we'll just do it. We'll do it together. I've got previous midterms. If we get it done really quick, then we can take a look at other midterms. The format of the midterm has already been posted on Piazza a couple of times. It's open book, open note, required computer because it is an executable exam. You'll be writing programs, you'll be given some starter code in some cases, and you will be submitting them through the web hand-in and using the web grader to check yourself. You can submit, resubmit as many times as you want during that exam time, which is 9 o'clock to 11:30 a.m. this Friday. And you'll be going to your regular lab hack session to hold that exam. So there is no lab, there is no hack this week. But of course your last hack, the GDB hack, is due tomorrow by midnight, okay? All right, so any questions on that? No? All right, then we're going to get into strings today. In C, a string is just an ordered sequence of characters. We've been referring to strings here using double quotes the entire time. You know, from the first program that you started printing hello world was a string. And you can put in special characters in strings using the backspace or backslash n to get an n-line character, backslash t to get a tab, etc. And you can use any ASCII text characters that you want. Some languages do support text characters beyond the ASCII text table. You know, Unicode characters where you can get CJK fonts, emojis and stuff like that, but C does not, natively at least, okay? In C, however, there is a big difference. There is a weird way that C represents strings, and it is as a character array. So if you've got an integer array with 10, 20, 30, 40, there are 4 elements in that array. A string array is just, instead of numbers, you're storing characters. But remember, at the end of the day, those are still numbers because of the ASCII text table, right? Capital A has an ASCII text value of 65. So if you store 65 there, you're actually storing the capital letter A, right? And they're simply null terminated arrays of characters. What do we mean by null terminated here? It means that every string has to end with this special character, right? It must be null terminated with this special character of /0. This is not something that gets printed, okay? If you try to print out /0, nothing will get printed. It's not null. It is not the n-line character. It is not 0, right? It is something completely different. It is the null terminating character. So don't conflate the null terminating character with, say, the n-line character, which is /n, and that is printable because it goes to the next line. It's not a 0 character. The 0 character is somewhere in there in the 40s or something like that, 48 maybe. I don't remember off the top of my head. And it is not the null pointer. The null pointer is technically under the hood, it's 0. You shouldn't conflate 0 with null pointer either. But it is not the same thing. This is not null, right? It has if you look at the ASCII text value, its ASCII text value is 0, so they kind of match in that sense, but it is completely different, okay? A string is not valid in C unless it is null terminated. If it's not null terminated and you say you have hello, right? 5 characters in there without the null terminating character at the end. Many functions will process this string, and it will process it until it sees that null terminating character, HELLO. And if it doesn't see that null terminating character, it's just going to continue. If you have an integer array with 10, 20, 30, 40, and 50, and you try to go past that, what happens? Hopefully, hopefully a seg fault. Otherwise, undefined behavior. It could just be that you're corrupting your own memory, and that's completely fine with C, right? So keep that in mind, that if you do not have that null terminating character, it is not a valid string, and you will get undefined behavior. Right? And sometimes it's going to be your responsibility to take care of that. Other times, C will take care of it for you. You just have to make sure to understand when and where it becomes your responsibility. Okay? So again, in C, strings are arrays of char elements. We've seen this before, right? Example, char, str 10, str 10. I don't think we've seen this one but yet, or char star, right? Char star, we've seen that before, maybe in main especially, char star star, right? What is that? Well, it's a two-dimensional array of characters. Each dimension is a string, right? And what is one string? It is an array of character elements, okay? It is not the same thing as an integer array, not int star or a double star or whatever. Ultimately, yes, integers are stored in there because you have the ASCII text table. Every character corresponds to some integer value. Again, capital A, that's going to be 65. So you could store 65 in there, but it's a little bit different because a char is only 8 bits, 1 byte. How many bytes is in an integer? Typically, 4, right? So if you tried to store character 8 million, right? That's not going to correspond to anything in the ASCII text table. You're going to have overflow or underflow or whatever the case may be, and you're going to get nonsense characters. Okay? So, how do we declare strings? Declaring strings. So for that, I'm going to come over here to our demo file, right? And let's go ahead and create a string that contains my name. Char name, or let's go with first name, or full first name, whatever. I'll just keep it first name here for a second. And how big does it need to be, right? If I want to assign this a value of Christopher, there we go, my full first name. So go ahead and count up the number of characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So would I be okay with getting by with 11 characters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, what comes at the end of the string again? The zero, the /0, the null terminating character. So if I only allowed 11 characters here, and my full name is 11 characters, then I would be missing out on the null terminating character. I wonder, can the compiler check for this? GCC demo.c. Let's turn on all the warning flags. It does. Well, okay, it catches it, but for different reasons, because we never actually use it. Unfortunately, it's not able to determine that you've created an array too small to hold my full name. Right? So let's come back over here and fix that. So 11 is too small to hold the null terminating character. Right? So let's not do it that way. Instead, what do we need to do to make sure that it's big enough? I could do 11 plus 1, or just do the math in my head and get 12. Right? There, that'll work. What if I don't want to do that? What if I want to elide that away? Remember that if we immediately assign, say, the primes, like the first 5 primes or something, to an array called primes, do we have to say that it's of size 5 if we assign 5 values to it immediately? Nope. What could we do instead? Char, first name, elide that away, take it away. We don't need that. Is equal to Christopher. There we go. And it'll automatically detect that, well, there are 11 characters there plus the null terminating character, so it must be 12, and it'll take care of all that detail for me, right? You can elide that away, right? Contents in a string can be changed, right? Using the regular array index syntax. So I intentionally left it with a lowercase c. How do we fix that? First name of 0, and I will assign that a character of C. Is this correct? Double quotes. Is double quotes how I get a single character? No. It is a single character. It would be single quotes. Right? In fact, I wonder what would happen if I did something like this. Get rid of that. Give myself some more room here so we can actually see the compiler output. Right? And it's complaining here that you cannot assign a char or to a char star. Remember that a string is going to be a char star. Double quotes are strings, which is an array of characters. This array is of size technically 1. It's actually technically 2. Why? The capital C plus that null terminating character. Right? And so I can assign a pointer value to a character, and so it does catch that. So let's change that to single quotes. Right?
Are you saying a single character doesn't need a null terminator?
Nope, because it's just number. It's just a number. Exactly. Right? It knows where to stop. There's 1 byte. I'm only going to read 1 byte. I don't need to say that. Oh, okay, well, there's 5 characters in here. How do I know that? Well, 1, 2, 3, 4, 5. Null terminating character. Now we're done. Right? All right. Good. So we can also print strings. You can print strings using printf and the placeholder. So the placeholder for integers was what again? %d. For characters, it's %c. For strings, what do you think it is? %s, exactly. Right. So printf, hello, and I'll print my name here. First name. So this should print out Christopher and then end the line. Right? And I'm not going to get any warnings now because I'm actually using that variable, and it works. Yeah?
I'm sorry for asking this, but the null terminating character, that's just 1 character that goes at the end, so you always need to add 1 to like however many letters are in it.
Exactly.
So the null terminating character is then,
That's
what's the actual, sorry, so it's
\0. And if you look at the ASCII text table, where is it? It's all the way at the beginning, null. This is the null terminating character, it should be.
So that just tells it like where the string ends, like as far
Exactly.
as memory goes.
Exactly. And in fact, let's take a look at a visualization of this. I'll retain the comments just because I don't want to delete them. But you'll see that it's going to create an array exactly of size 12.
So all strings go in an array, then like whenever you declared it, just automatically puts it.
Well, if you declare it like this, there are other ways of declaring it. This is a static string. Of course, we're going to want to work with dynamic memory here in a moment.
But pretty much all strings are like arrays.
They're always arrays of characters. Yep.
Okay.
So in the first line here, it establishes an array of how big? How big is it? Well, it goes up to index 11, but because you start at 0, it is 12, right? And it puts in there CHRISTOPHER, and then what does it put in there at the end automatically? The null terminating character. Right? And then we end up changing that first value to a capital C, right? And then we end up printing it, and we get that message. Okay? What do you think happens if I screw this up? What do you think happens if I say, okay, go ahead and set that to C, and first name of, say, 11 is equal to a exclamation point. Let's visualize that execution. Next, next, next. What's going to happen to that null terminating character? Gone. Is that a valid string anymore? Nope. If I try to work with this, if I try to print it, if I try to process it or use it with another string, what's going to happen? Maybe a segmentation fault, maybe a bus error, maybe a stack smashing event, maybe anything, right? You're crossing your fingers and hoping that you're not corrupting your own memory. Let's find out what happens here. Nothing, so the bug didn't manifest, but that doesn't mean that this was okay, right? We were screwing up our memory here, right? And just to prove this to you, let's go ahead and edit this code. Actually, let's edit it over here. Let me go ahead and change my first name of 11 to, there we go. There we go. And I'm going to make this much, much larger. Say, I don't know, let's just make it really, really large here, 10,000, okay? Now, I've made this have a capacity of 10,000 minus 1, so 9,999, right? Why minus 1? Because of that null terminating character at the end. When I assigned Christopher to it, that assigned the first 10 characters, or 11 characters, plus the null terminating character. What about the 9,000 or so other characters? Undefined, right? It could be dead beef, it could be garbage, it could be anything. Let's find out what's in there. Right? In fact, let me go ahead and make it so that the screw up is after the fact. Right? And instead of printing it out and crossing our fingers and hoping that it works, let's go ahead and go into a for loop here for int I equals 0, I is less than 10,000, I plus plus, and let's print out each character by itself. Printf let's see, first name of I is equal to %, and then I will print out a single character, each one to a line, right? And maybe not go 10,000, but let's go up to the first 1,000 here, because I don't want to print all of it. But first name, like I, and then first name sub I. There we go. And compile that, and let's run it. So now the vast majority of them are going to be zeros, right? That's not always going to be, come on, really? You were behaving so well before, but now you're misbehaving, and oh, I didn't screw it up. Whoops. What did I do? I just reset it to the null terminated character. So let's reset it to this and see what happens. In fact, let's print it out again and see if it fixes it or screws it up. I'm trying to intentionally screw this up, but it's not going to play nice with me right now. I want you to screw up to show that I'm not crazy, right? But it is going to zero out all those bytes for some reason. Yeah.
So if you were to put in a null terminating character like you did and then declare the string to be a larger size after that, like when you said, like you declared it to be 10,000 and then you put in the null terminating character at 11, it would automatically put a 0 after all of that?
Not necessarily. That's this compiler, that's this operating system taking care of that for me.
So then what would happen if you had like 2 null terminating characters? Like I know you said it.
These are probably null terminating characters, which has a value of 0. So it is filling it up with zeros, but there's no guarantee on that.
So,
It could just be some random number.
So just anything can happen after if you put 2 of them in.
Anything can happen.
So just don't do it.
Yep, don't do it. But you can do things like this. Okay, let me get rid of this since it didn't work out for me. First name. Maybe I only want my nickname or whatever, right? CHRIS. So 0, 1, 2, 3, 4, and then 5. I'll set 5 equal to the null terminating character, right? And then print it out again. Let's see that in action. Hello, Christopher. And then I basically truncated it temporarily, and I'm printing out only the first 5 letters of my name, Chris. Right? Does that actually change, and let's kick this back down to whatever, right? Does that actually change the contents of the rest of the string? Let's find out. It changes the T, definitely. Right? It changes it to the null terminating character. But what about the OPHER and the null terminating character after that? Nope. It stays the same. So first name gets truncated. See, we just changed that one character. The OPHER and the null terminating character are still there. The size is still 12, right? Et cetera, et cetera. But I have effectively made the string smaller, right? Again, with strings, the null terminating character determines the end of the string. If you reset the null terminating character, then you'll get different results, okay? But it doesn't change the actual memory under the hood. The memory is still of size 12, all right? The old contents are still there. If there were garbage contents before, those garbage contents are still there, okay?
So if you wanted an array of, let's say, people,
Mm-hmm.
so if you have a 2D array.
If you want names, right,
Yeah.
then it would be something like char star star,
Yeah.
right?
But the memory for it, so your largest name would occupy the most amount of memory, right?
Sure.
And then that amount of memory would be allocated for every name.
It depends on how you allocate it. So if you allocate it so that everything has the same size, right? Christopher, the 12, and then Joe, Anne, right? Bonita, whatever, right? Then when you call, when you go into your loop, you've got your array of pointers. That's your first one. But then when each pointer, instead of allocating the same amount of bytes every single time, 5 bytes here, 12 bytes there, 13 bytes there, whatever you want. It's just easier to make it a full 2-dimensional array, though. It doesn't matter that you're wasting space. Right? Yep. Now, char star argv won't do that. Char star argv will actually go with that hybrid approach that is in the videos and in the book that I didn't cover, that it'll just allocate one contiguous array and then make pointers to each one of those. Right? So that there's no wasted space at all. But then you've got this string, a null terminating character, another string, a null terminating character, et cetera, et cetera. And then do not screw with that at all, right? We'll have cause to screw with that later on when we do tokenization. but that's next week. We'll hold off on that. Right? Okay. So another thing to note here, I'll make sure that you have this in the notes.
So if you were to
Yeah, go ahead.
reset an old terminating character, you would have to reset it again if you wanted to just like, say you wanted to print like half of your array for like one line, then you wanted to print the full thing after that, you would have to reset it again.
If you want to use printf and the %s, if you wanted to roll your own print function where you print character, 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 then you can do that, I suppose. But I wouldn't do that.
Okay.
You can always reset it, right? So let's edit this code here and fix my name to be what it was before. Let's see, Chris, we screwed up the T. So let's visualize this execution, and we'll see that it's now restored to the full name that we had before. There we go. So there is the truncated version, and then we print it, and then we put it back to a T, making it a full-length string again. Okay. What you cannot do, however, let me give myself some more room here, sorry. There we go. All right. String assignments, or assigning strings, right? Once you have created a static string, you cannot reassign it. Right? You can only change individual characters in the array. Right? So for example, let's come back over here. Let's go to the full demo over here. And let's go all the way back. Let's go ahead and get rid of all this stuff. There's my first name, and I've decided, oh wait, no, I've screwed up. I don't want my first name to be Chris. If I did this, first name is equal to Chris. There we go. You cannot do something like this, and the compiler won't even let you do it, right? In fact, it's a full error now, not just a warning. Why? Because you have a pointer reassignment, right? After you've created your array, it is going to be of size 12, right? Attempts to say Christopher, Michael Burke. Would that ever work? Remember that it's going to be of size 12, right? Can I fit this big giant string here, which is certainly more than 12 characters, into this array over here that is of size exactly 12? No. So it's not even going to let me do something like that. So the question is, once you've created a string, how do you assign a value to it? To assign a value to a string, right, that is, place the contents of one string into another string, you use strcpy. strcpy, what do you think that stands for, or what's that shortened for? String and then copy, right? And it is it along with many other functions that operate on strings can be found in the string.h library. Right? I don't know if I'm bringing that in here. No, I'm not, so I'm going to show you how to do this instead. I'll just make this super, super big so that I don't want to go through and count up the number of characters here. You could do that using an online character counter tool, or there is a command line tool that allows you to do it. Let me go ahead and put this here, echo this, and then pipe it into word count character. 27. Cool, there are 27 characters there. That's not counting the double quotes there. So I don't know, do you take Unix programming course here at UNO? No? Not, maybe eventually? Okay, well, you pick it up on your way or, at some point. Unix tools like this are super, super useful. It will make you a million times more productive than somebody that's using just a graphical user interface and pointing and clicking 50 different clicks to get to one report. The Unix philosophy is that you build a lot of small little programs and then you can string them together like this. This vertical character here, that's called a pipe. You are piping the output of one utility into the input of another utility, and then you can continue to do that over and over and over again. It's super, super useful, and it's a really great philosophy of building a lot of small, little, tiny tools that you can then, combine and recombine and do a lot of powerful stuff. Once you get the hang of it, you'll never go back, right? Instead of massaging a bunch of CSV or Excel data over hours and hours and hours of work, you can write one script and get everything done in 1 second. Right? All this was word count, and then instead of counting words, I wanted to count characters. If I just did words, it would probably tell me 3 because there are 3 names there. Right? Oh, it told me everything. There is 1 line, 3 words, and 27 characters. You can pipe that into awk, and then print, a more complicated way of doing this, print the third one, and get 27 back out of it. Right? You can pipe that. You can pipe it in and add them all together, or do whatever you want. Right? Anything that you want, you can do. It's at your fingertips at the command line with just a few simple tools: awk, grep, echo, more, stuff like that. Okay. Anyway, back to this at hand. I cannot do this. You cannot simply use the assignment operator. So instead, what I have to do is I have to use strcpy. strcpy takes 2 arguments. In fact, let's go ahead and look at the man pages for strcpy and see what it calls it on this system. Oh, come on, really? All right, fine. I'll bring over my man pages instead into the notes. And let's go ahead and take a look at it. strcpy, don't worry about the return value here. It just returns the result. You can ignore it. Otherwise, it has a destination as the left argument and then a source as the right argument. So what is it doing? It's taking the source and placing it, the contents of the source, and placing it into the contents, into the string pointed to by destination. What does that look like? Taking the thing on the right and putting it into the thing on the left? X is equal to 42. You take 42 and you put it into X, right? It's the same exact pattern. Right? So how do we work it here? First name, I will copy into my full name, Christopher Michael Burke. There we go. And then I can print it out. Printf, hello, %s, and the line, first name. Now it's not called first name anymore, but it's my full name, but I'll keep the variable name. Right? And it's complaining why? Because that's located where? In the string library. So string.h. Once I bring that in, then it's happy. And if I run it, I can see Christopher Michael Burke there. Right? Again, what happens if I make this too small? Only 20. Remember, it said it was 27. Is that going to fit anymore? Nope. So I wonder what's going to happen here. Oh, it knows about it already, right? With the full warnings enabled, it's saying, wait, there are 27 bytes into a region of 20 bytes, overflows that destination. It's just a warning. All right, if you really want to do that, go ahead. I wonder what happens, though. Oh, stack smashing event. Excellent. Right? I like that because now we're corrupting the stack space memory. Right? Let's fix it. Let's fix it so that we don't have the warnings anymore. Instead of having a static string, let's make a dynamic string. Remember the difference. If I have an integer array, ARR, of size 10, right, I can assign the values 2, 3, 4, 5, 6, 7, 8, 9, whatever, however many there are, 10, 11, 12, whatever, right? That's going to be a static array. What's the difference between that and, say, int star array is equal to, what do I call now? To dynamically allocate this? Malloc, right? Those two things are going to be the difference between a static string, which is what we started out with here, and a dynamic string. So let's dynamically allocate enough space. So char star instead, and I'll still call it first name. Name, and I will call malloc here. How do I call malloc in this case? So I need to, of course, or I should, typecast it as what? Char star. And how many bytes do you want now? Size of char. Now technically that's always going to be 1. Still write it like this. because you could port it over to a system where there is for some reason, there's a different char. Like, it could be a full Unicode support, and then it has up to 4 bytes instead of just 1 byte for a character. Leave it like this. How many do you want? Well, I'll just say 20 at most. Right? That's what I was doing before to screw this up, right? Let's find out what happens here. GCC. Oh, Christopher Michael Borum, right? That's memory corruption right there, right? So why is it not working? Well, let's go ahead and use that one of those tools that we've discussed before. I'll grind a.out, right? And let's get a report for what happened, right? There are 24 errors from 8 different contexts. Wow, that's a lot, right? So there's a memcached, let's go all the way to the top. Can't believe that it's that much, but there was a invalid write of size 8. Address, whatever. Where did it occur? Does this report tell you that? Nope. Why? What did I fail to do? Let's go back to the compilation process here.
You need to compile it so Valorant can see all your...
And to do that, it is the G flag. There we go. All right. And so let's run valgrind again, and we see a different report now with actual line numbers. Let's clear that out. I don't know where it was. All right, there we go. Where? In demo C, line 15. When we were trying to copy something that was, there was 20 bytes allocated, but we were trying to copy something that was way more than 20 bytes. Not way more than 20 bytes, but whatever. All right. Okay, let's go back to the drawing board. 27 bytes. Is that going to work? No, why not? Let's ask valgrind again. There's now 1 error. What's that 1 error?
You didn't leave enough space
For the null terminating character, exactly. So if there are 27 characters in Christopher Michael Burke, with those 2 spaces count, right? Then you need +1 for the null terminating character. Do not get in the habit of this. That will work, but that's only because a character is only 1 byte. Right? Is that correct math? No. What would I need to do? 27 plus 1 in parentheses. Or just do the math yourself. Yeah?
So, like, I remember when we were doing this for arrays, we would say size of int times, like, n, and that's, like, the number of things in your array. Is there a way to do that with this, or do you just have to know how many?
There you go. But you're probably thinking, well, if you have the string already, how do you determine how many characters are in it?
Yeah,
That's your
do you have to
question.
know how many characters are in how many characters are in the string when you're doing this, or is there a way to just allocate so much memory that it's...
I mean, you wouldn't want to allocate like 1 billion
Yeah.
bytes for my first name or something like that. But yes, there is a way. Hold on to that thought, and we'll look at that in a second. Before we do that, though, let's go ahead and make sure that this actually works now. Let's run it through valgrind, and we get, 1 error. Well, there's only 1 error because we never freed this up. There's a leak summary. After I print it out, I should free it up. First name. Right? If you want to get pedantic about it, right? That is a good word, pedantic. Too strict, right? Define pedantic. Right? Characterized by a narrow, often ostentatious concern for academic knowledge or formal rules. Formal rules is what we're talking about here. In fact, you can compile with a pedantic flag. What this will do is it will take you back to good old 1979 and all of the pedantic rules that applied there. Looks like it was a small enough program that it doesn't matter. But for example, using a for loop with a loop scoped integer variable, not allowed in 1979. Declaring a variable down here on line 70 after having declared other variables up here, not allowed in 1979. You had to create all of your variables up here at the top. Right? Don't worry about it.
Why?
Don't use the pedantic. Well, think about you're in 1979 and you're a compiler writer, right? The stricter rules you have, the less code you need to write as the compiler writer, right? So, no, you can't do that. No, you can't do that. No, you can't do that. Then I don't have to code for it, right? So, that's why, of course, now you write more flexible compilers, allow people, a little bit looser rules or whatever, but then it's on you now, the compiler writer, to take care of all those rules. Right? Another language like that is PHP. where they have a rule that every variable name has to begin with a $sign. Why? Because I didn't want to write any more rules. That's not me. It's Rasmus Lerdorf. He didn't want to write complex interpreter rules. He just wanted to keep it simple so that he could just get it done. All right. So your question, how do we know that it's 28? Right. All right. Let's go ahead and come down here before we freed it, and let's determine how many characters are in first name. So we could go ahead and roll our own solution here. Int num characters, chars, is equal to 0. And then for, or while, right? What I'll do is I'll take another character here, current, is equal to, or no, let's go with an index variable here. I is equal to 0. Right? And while the ith character of first name is not the null terminating character, then I will go ahead and increment both my counter, I plus plus, or num chars plus plus, and I plus plus. We'll break out of this while loop when we hit that null terminating character at the end. Why did I use a while loop here? If I knew the answer 27 up front, then why am I writing this loop to begin with? Right? What do you? Good question. For clarity here, I would. We're going to end up deleting all this anyway because there's a better solution for demonstration purposes. Right? Num chars. Right. So the string. Oh, now how do I quote a string here? Has %d characters. So I will print out the string, which is first name.
Is it %s?
I'll need to do %s, but how do I put?
Escape the quotes.
Escape the quotes. There you go. Let's go ahead and compile that and run it. There. The string Christopher Michael Burke has 26 characters. Is that right? No. What was it? Oh, it should be 27, right? So what did I do? I was off by 1. So I should start at 1 or what? Negative 1?
No.
I'm down by 1. I need to start it at 1. But what if it doesn't have any characters? You know what? Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Oh, okay. I was off. I don't know what WC was telling me then. There are 26.
Was it counting the null terminating there?
It might have, probably not. I'm not sure what it was counting there. Come on, WC. Echo that word count character. I don't know why it's saying 27. We can always test that theory. Nope, it's still 26 and 27. Okay, I'm not sure, but we got the right answer. I'm convinced that we got the right answer of 26. What happens if we screw it up? First name of, there are 26, so at 26, I will change that null terminating character, which was taken care of for me by string copy, by the way, and I will change it into a exclamation point. At that point, is first name a valid string anymore in C? Nope, the null terminating character has gone by. So let's find out what happens. There's probably null terminating characters in there anyway, 0 bytes, but let's find out. Oops, there we go. Has 27 characters now. So it did actually successfully stop after that, but that's because we got lucky. Yep. Yeah.
Google tells me it's counting the new line character.
Oh, is it?
Yeah, it says if you do echo.
Oh, okay, because echo is doing, okay, all right, fine. How do I do E?
Hyphen N.
Oh, is it hyphen N?
Yeah, echo hyphen N looks like.
Oh, nope.
That's worse.
Oh, that's, There we go. I don't know what it does after the fact, but it probably ignores it or something like that. Thank you, though. There we go. So it's not putting that new line character in there with a hyphen N. Good. I thought it was hyphen E. What does hyphen E do? Nah, nothing. Maybe it's ignored. Good. Excellent. Do you want to write this every single time? Nope. You could put it in a function, or you could consult your friendly string library. This probably is so common that there's probably something in there for it. str, if you want the length of a string, all you need to do is call strlen. Give it the string, first name, and that tells you how many characters there are. Int num char z is equal to string len, strlen, short for string length. And run it. There we go. And it's 26 characters still. Right? And I'm not screwing it up anymore. I erased that, that code that did that. Right? What do you think it's doing under the hood? It's just a while loop that goes through and counts them. Right? It's pretty, a little bit more sophisticated than that, but that's what it ends up doing. Okay? All right. So let's go back over here and talk a little bit more about strcpy. First of all, there are several assumptions here. Let me go in like that. There we go. It assumes that the destination string is big enough to hold whatever you're trying to copy into it. It is your responsibility to take care of that. If you try to copy in that full name, Christopher Michael Burke, very, very long name, into an array of size 20, you're going to have undefined behavior. Run it through Valgrind and it'll tell you there are a whole bunch of errors here. Right? It assumes that the source is a valid null terminated string. If that's not the case, then again you have undefined behavior. When you have a hard-coded string like this, with double quotes, then it automatically takes care of that null terminating character for you. strcpy will also take care of the null terminating character. So it also takes care of the null terminator in the destination string for you, right? Under those other assumptions. Right? Note, the second argument, or a parameter, is const. The first is not. Right? The first one, char star destination. The second one, const char star source. What does that tell you about these two arguments? Is it going to change source? Nope, it can't. Is it going to change destination? Yes, that's what you want, right? It's going to copy this thing into that thing, right? Overriding whatever was in there before. So if you were storing something super important in that first string, it is now gone, right? So back it up if you want to. Right? There's also a byte limited version, strncpy. Right? It only copies the first n bytes or characters in the source string. Let's go ahead and take a look at its usage here. So I'll just make this big enough to hold whatever we're going to do here. And I'll say, here's my full name, and here's my first name, char star first name is equal to another call to malloc here. But I only need, how many characters did we start out with for my first name, Christopher? I believe it was 12. 11 actual characters plus the null terminating character. And what I can do is I can try to strcpy into my first name the contents of my full name after I copy them in. So sorry, let's do that first. Our strcpy into my full name, Christopher Michael Burke. There we go. Now you know my middle name. All right, and I'll try to copy in my full name into my first name, but will that work? Will 27 bytes, or 26, yeah, 27 bytes, which include the null terminating character, will that be copyable into an array of size 12? No. All I really want is this first part right here. So instead of strcpy copy everything, I'll say strncpy only the first 11 characters. Right? Let's take a look at the the signature for that thing, right? So it's strncpy, still a destination string, still a source string, but it takes this third argument, n, the maximum number of bytes that you want to copy. So in this case, it's only 11. Why not 12? Christopher, what would 12 be? There's 11, and then 12 would be that space there. Right? I only want to copy the first 11 over. But now what about that null terminating character? strncpy does not necessarily take care of the null terminator for you. Right? The null terminator for you. Look at those first 11 bytes. You can't see the null terminator ever because it's not a printable character. But is there a null terminating character in those first 11 bytes? Those first 11 bytes that are highlighted right there. Nope. So when I copy over CHRISTOPHER, the null terminating character is not taken care of for me. So what do I have to do? In this case, you must manually take care of it. I'm going to set the last one to the null terminating character. First name of 11. Why 11? Because you start at 0, 12 characters. The 12th one is going to be at index 11. And I will set that to the null terminating character. Printf, hello, %s, and the line, first name. There we go.
Do you have to, like, put the null terminating character like that? Do you have to do it before you try and copy, like, before you try and do string copy or not, or does it matter?
So this one does not have to be a proper null terminated character. The destination doesn't have to be proper null terminated because it's going to be overwritten anyway. The source does have to be a proper null terminated character. In this case, it's just a static double quoted string, so the compiler takes care of that for me.
Okay, but before the second one, do you have to declare it before then or not?
Nope, because again, the first name, it's just a character array with 12 bytes, right? That's the destination. The source here is already a null terminated character array because of strcopy takes care of that for us. Right? In this case, though, strncpy does not see the null terminator in the first 11 bytes, and so therefore we have to take care of it ourselves. Right? Okay.
Can you use string length on the first name?
Say again.
Can you use string length on the first name?
Only after it has been made into a valid string. So for example, if I did int n equals strlen of full name, right?
Yeah.
Invalid. Why? Because it's not been initialized to anything, right? If I did that after I did a copy, then it would be valid.
So it's always invalid until you put the null terminator.
Exactly, right? It has to have a null terminating character. So if you wanted to, what you could do is you could say full name. Just go ahead and at the very beginning, go ahead and make it into a null terminated character at the very beginning, just like you would with, say, a pointer. You declare a pointer and you immediately set it to null just in case. Right? Here, I'm setting it to the empty string, right? This is the empty string. What is its length, do you think? If it has nothing in it, its length is? There's nothing between my hands. So nothing is 0, right? And there we go. Now it's valid. Right? And it'll return 26 or whatever it was. Actually, no, sorry. Here it'll be size is 0. The length is 0.
So if you initialize first name, so I see the string copy first name, you're putting the full name only 11 bytes into the first name, right?
And this in strncpy, that's correct. Yep.
Yeah. And then you're putting your null terminator afterward. If you put it before, you could use string length in your string copy.
This strncpy would still not take care of it for you because it does not see that null terminating character in the first n bytes. You said copy at most n bytes, right? So it will copy at most n bytes, and that's all it will do, right? If the null terminating character occurs within the first n bytes, those first 11 bytes, then it'll take care of it for you. Right? But if it does not contain that null terminating character within the first n bytes, it will not copy the null terminating character for you, and you need to take care of it yourself.
Yes, I'm saying once you initialize an null terminator, you don't statically say 11, you say string length first name.
In the line 6, here.
Line 19, say first name 11 equals the null terminator, and then in line now it's 21, instead of 11, say string length first name. So now we have a null terminator.
Then you could call strlen on first name. This would be valid.
And
Yes.
then put that where the 11 is.
And then put,
Line 22 now,
all right.
where you have 11.
Not necessarily, because what those first 11 characters, they could be J, Q, P, S, T, then the null terminating character, right? You're asking, what's the length of this thing that I haven't even created yet?
It doesn't matter as long as it fits a null terminator, right?
Well, you could, it could be the case that first name of 0 is the null terminating character as well. Null terminating character, there we go, right? And then strlen would end up being 0, and then you copy only 0 bytes, right? So that's not what you want to do, right?
Well, I was just thinking the way, I guess in our usage
There we
case, it would make sense, but it wouldn't make sense for.
yeah, not generally, no. Right. Okay, so you can use pointer arithmetic and strncpy to get substrings. So this is another trick. So what I want is, I don't want my first name, I want my middle name. Right? How do I go about copying just the middle part of one string into another string? So let's go ahead and try that. Char, and I'll just go middle name, and I'll just make this into a static string, it doesn't matter. Michael is 7, so is that going to be enough? Nope. What do I need to do? +1. Right? And if I just did this, strncpy into middle name, my full name, at most 8 bytes, and then took care of the null terminating character myself, middle name of 8 is equal to the null terminating character, right? And I can print this out, printf, middle name is equal to %s and the line, middle name. Hopefully this compiles, because I screwed up a bunch of other stuff there. Yeah, okay, those are just warnings because I'm not actually using that stuff. But I'll go ahead and run this here. And my middle name is Christop. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8. Oh, was it 8? I should have done 7, right? There we go. There we go. That's not my middle name. What was my middle name? Michael. Where did that start? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, at 12, right? Full name of 12. Oops. But is that correct? Can you, what is it expecting here? A char star. One element in a character array is a regular old char. So this is going to complain. In fact, it's just going to be a warning. Yeah, it's just a warning. That you're passing that this thing is a character, right? And that it's expecting a char star. There we go, const char star. Okay? So how do I make a char into a char star? How do I make a regular old integer into an integer pointer? It's a regular into a reference, a regular into a pointer, so ampersand. Yep. And again, you just have to put that up on a post-it note next to your computer. Dereferencing operator, star. Referencing operator like this, ampersand. And when I do that, same warnings as before, but there. Now Michael is being copied. I started in the middle of a string, and I got the memory address of that, and then I used strncpy to only copy part of the string, but starting in the middle. Right. Okay, I'll make sure that you have all of this in the notes. Questions so far? No? Okay. Let's see. One thing to note about the string length, by the way, let's go back over here to the notes, is that it does not include the null terminating character. So Michael, M-I-C-H-E-A-L, that's 7 characters. strlen will tell you 7. It does not tell you include the null terminating character. So if you ever actually want to copy over a string, what would it look like? Let's go ahead and get rid of all of this. I have a string, say, char star, or char name is equal to Christopher, right? And I want to make a completely new copy, right? A deep copy. Do we remember deep copies versus shallow copies? This is a shallow copy, right? Can I make changes to one without affecting the other in the shallow copy? Nope. They're pointing to the same thing. Changes to one affect the other. I want a deep copy. So what would that look like? I would have to call malloc. I would have to typecast the result. And how many bytes do you want? Size of char times how many bytes are in name? String length name. Except that it does not include that null terminating character. So what would it say in this case? One less than it needs to be. So +1. Yeah, there you go. Parentheses. Do good math. Good math, valid math. All right. Again, it all washes out in the end because everything is just a byte, but have good practice. Yeah.
So a deep copy is like creating a whole new copy of something else, where like a shallow copy is just like this equals this.
Exactly. So let's also go with shallow copy. Shallow copy is equal to name. And I'll show this to you in the visualizer here in a second after we've finished. And let's go ahead and go strcpy, because does deep copy right now contain Christopher? Nope. I need to go strcpy into deep copy name. Okay? Now that's just the code. Let's visualize it. Both a shallow and a deep copy string.
I don't understand the purpose of the shallow copy.
Well, any pass by reference is going to be a shallow copy. If I want to pass an array containing 1,000,000 integers, I don't want to copy 1,000,000 integers if I know that you're not going to make changes to it because you're const, right?
Are you talking about the stack?
No, like dynamic, right? Here, I want you to sum up all these numbers like you did in lab, right? You're not going to make changes. Do I need to make a copy of all this stuff so that you can sum it up? No. I could just give you a shallow copy of it and pass by reference. All right. So there is the initialization of the first string, Christopher, with the null terminating character. The shallow copy, however, that's just a pointer that points to the exact same string. But a deep copy is going to be a brand new array created dynamically on the thing we call the heap instead of the stack. And strcpy takes the contents of this and copies it over here. Two different things are deep copies. The same thing with two different pointers or references to the same thing is a shallow copy. All right? That seems like such a useful feature. I want a deep copy of a string. I want a deep copy of a string. Maybe we should do what? Make a function. And unfortunately, there is no standard C library string function to do this, so you have to roll your own here. Char star deep string copy. And we'll take a const char star s. Unlike other arrays where if we wanted to do something with the sum of integers, what else do I have to tell the function? how big the array is. This is a string array, or this is a character array, though, a string. Do we have to tell the function how big it is? Not if they have access to the string library, right? So let's copy this over, get rid of the shallow copy. The deep copy will simply be a malloc and a call to string length +1. It doesn't need to be told how big that string is, right? Generally, you would put int n to say that there are 50 integers in this array. We don't have to do that here because it has access to the string length, string library and string length. We do a string copy and then we return deep copy. There we go. And I don't have to do this part anymore. I can just call my deep string copy function on name and be done with it. Cool. Print it out. Printf original is going to be %s and line name copy, their deep copy will be the deep copy. Right. And then let's change one. I don't know, let's go ahead and say name of 5 is equal to the null terminating character. I'll change it into Chris, but that does not change the deep copy. Oops, name. Oh, S, there we go. Was that what you were going to point out?
I was gonna ask, I thought we did like write a prototype first before.
You should. This is just the quick and dirty demonstration way of doing it.
But you don't always have to do that, it's just.
Yeah, if you're putting something into a header file, yes, you should. This is the proper way. And what else is proper to do? Documentation makes a deep copy of the given string. Why did I make it const? You're not going to be making changes to it. You're just going to be looking at it to make a copy of it for it, right? And then it's down here. I saved it, right? There we go. Let's run it again. There. The original has been changed, but the deep copy has not. Right? Cool. Right. Is there something else? I don't think that there is something else. Oh, well, yes, of course. As any good programmer that doesn't want to do something right now, I will go ahead and put in a to-do. And what should I be doing? Basic error handling. All right, now, as a better programmer, let's go ahead and take care of that programming right now. What's one possible error condition here?
R is null.
Okay, the S is null.
S is null.
S, if that's null, what can we do? Can we return an error code the way that we've designed this function? No. So what's a value that we could return to indicate, look, you gave me null, I'm going to give you something back to say that something happened? Null. It's the only thing that can happen, that you can return. And it actually makes sense, right? You give me null and you want a copy of it, oh, okay, here's null, right? And that makes sense, right? So here's another question. Oh, I made a deep copy. Should I free it up? Is it this function's responsibility to clean up? No. It's giving it back, right? You asked me for a copy. Does it mean the way that I've written this code is I make a copy and then I throw it in the garbage, right? Can I give it back to you? No.
Not easily.
Not easily. Not at all, actually, because otherwise then it will be, any attempts to access it will be undefined behavior, right? There is no undelete, so you can, if it's a literal garbage can, you can always take it out. If it's your Windows machine, you can, or I guess Mac even, you can open up your recycle bin, or what is it in Windows? Recycle bin, and what is it in Mac? It's a trash bin? Okay. So that's kind of backwards, isn't it? It's supposed to be recycling with Apple stuff, right? I don't know. Anyway, if I deleted it here, I couldn't give it back to you. Whose responsibility is it to delete it or to free it up? In this case, main. But of course, since it's a short ephemeral program, it doesn't matter if you do it here or not. Well, Valgrind will care that you didn't do it. But in this case, since you're at the end of the main anyway, who cares? Right? But if you are debugging something and you've got, say, 50 million errors from Valgrind because you didn't clean this up, go back, clean them up so that you can isolate which errors are actually occurring. There. I think that this will give Valgrind will give a clean bill of health to this, definitely. Okay, Valgrind a.up. Should have just typed it. 0 errors from 0 contexts. Excellent. Okay. Any questions? No? All right, well, we will get into string processing, but I want to wait until next time for that. We're going to talk about string concatenation and string tokenization. Oops, sorry. Tokenization. For tokenization, what I want to do is I want to give you a piece of data here. Text. All right, do I have a piece of data here to look at? Oh, okay, well, here. I live over in Shore on US, that's my home, I live in Omaha, but my office is over in Shore 103, or 103 Shore, there we go. One of my office mates is Bonita, Sharif, and I don't know what her NUID is, so I'll just say 1234. I believe that she does live in Lincoln, Nebraska, and she's right down the door, right in the next door to me. I don't know what number it is, but she's in that Shore. Right? Joe Smith. Their NUID is 5678 or something like that, and they live in, I don't know, Georgia. Okay, well, give me a town in Georgia. Atlanta, Georgia. All right. They have $35 million payroll this year. No, is it the Atlanta Braves or is it now the Guardians? No, it's the Guardians. Never mind. The Guardians have a $35 million payroll. It's ludicrously low. Nobody follows baseball, so never mind. 120 foo. All right, there we go. Take a look at that data and tell me, what is it? What kind of data is that? Names, address, yeah. What about the formatting?
It's kind of like a list.
It's a list delimited by commas, comma, separated values, or CSV. Right? Where have you seen kind of CSV data before?
Is that a file extension?
It's a file extension, yeah, CSV. And if you were to double click on a file with CSV, what would you normally pop up? Microsoft Excel, right? No, it'll open it up in Excel, right? In fact, if I put this into a file right now, we could just double click on it, it would most likely open up in Excel. This is one way of representing data, right? That you have these, each one of these things are tokens. Each item is a token. Right? Splitting up, or each line is a record. Right? Splitting up a token, the tokens on each line is called tokenization. Right? It's one way of processing. This is called a flat data format, right? You've taken some sort of data model. In this case, it's first name, last name, NUID, city, state, and then your office number. And you are taking it and you're flattening it out so that everything is in one big giant line. You could, of course, put a header in it, and it would look something like, say, first, comma, last, comma, NUID, comma, city, state, and then office. Right, there we go. So the first one is usually a header, right? And if you were to open this up in Excel, it would automatically split it up for you. It would automatically tokenize it so that the first column in Excel would be the first names. The second column would be the last names. The third column would be NUIDs, et cetera, right? How do we do that in C? We're going to take a look at a tool called strtoke, which is short for string tokenization, to do this for us. Right? But otherwise, that's one way of representing data, one of the very, very simplest ways of representing data as strings in a file. And file IO is actually next. do not have to worry about strings on your midterm. Your midterm only covers up to and including arrays. Debugging, yes, in the sense that you probably will want to use a debugger if you've got problems on your midterm. Okay? Yeah.
I just have a question. What's like the format of the array? Is it like multiple choice or like short?
Oh no,
answer?
you're writing programs. And
Okay, so is it kind of like a lab where you just like get something and you can write?
kind of, yeah. I mean, if you want to, I can, where is my handout for fall midterm? There we go. So here's the midterm from fall 21. Right? So one of them, they were actually given 24 hours for this, so it's a little bit not as long, but it's kind of the same basic format. They were given a problem statement here with a bunch of just formulas for win expectation, and they had to, in fact, no, I didn't do this in this class. This is the expected win, this is the win percentage, and then these are the predicted wins based on formulas. So here's a bunch of formulas. Write a program that takes input and produces this output. Straightforward, right? Not even any loops in this one. Second part was arrays. So I gave them a tester, for example, and I did the same thing for you guys. I gave you a tester that demonstrates each one of these. Sum up all the elements in this array, but only if they're positive. Right? Given two arrays, append them together. So here's array 1, here's array 2. Make a new array that is, the array is combined like this. Right? Molt table, that looks familiar, you did that in your lab. Right? And that was it for last semester. They were given 24 hours to do that. You'll have 2.5 hours, so it won't be as long as this, but it will be, this was timed at 2 hours anyway. Right? Yeah?
Would this be like, graded like the labs or the hacks, but like
Yep.
where style matters?
Style, documentation, design,
Okay.
and then more heavily towards correctness, of course. And then the grader is already set up. You submit your files, you can grade, you can resubmit as many times as you want in the 2.5 hours. But this is what we'll do next time. We'll go ahead and do this midterm on Wednesday.
A question on the strings.
Yeah.
Interpretation. Will we have to create our own tokenizer?
Nope, STR toke.
Oh.
You do have to know how to use it though. Any delimiter, yep. In fact, a collection of delimiters.